Welcome everybody. This is a new topic, Chapter 10A from Cambridge Text. It covers the same material as Chapter 23 of your school textbook. Cambridge just has a little bit more detail. Today's topic is scatter diagrams. Scatter diagrams are fairly simple, so we'll go through it quite quickly. We're only looking at qualitative information about scatter diagrams today. However, these are a few of the words you need to understand in relation to a scatter diagram, or scatter plots as they are more properly known. So independent variable, dependent variable, correlation, causation, positive correlation, negative correlation, linear correlation, and non-linear correlation. All of these probably mean not a lot at the moment, but by the end we'll have at least a start of an idea. A scatter diagram is a diagram where you plot the coordinates of an independent variable and a dependent variable. An independent variable is the one that does its own thing, so it's the x values. Does its own thing. Where are we? Draw. And the dependent variable, which funnily enough depends on the value of x. So that's why we have functions of x. It'll come clear a bit later on. We just put a dot where the x and y coordinates say to put them. Alright. If the dots form a pattern that is generally upwards, generally up, we say that's a positive correlation. And if they're generally down, we say it's a negative. So a correlation is how much or the direction one thing moves relative to another. Can't think of a good example, but anyway. When they are all over the joint, there is no correlation. So no correlation. Alright, so when we're trying to talk about the general shapes in a scatter plot, we are looking whether it is a strong, moderate or weak correlation, and whether it's positive or negative, or there's no correlation, or it's a non-linear correlation. And all of these things we will develop mathematically as well as graphically, as in this video. In the first one here, which I will label 1, we can see it's pretty easy to draw a single straight line that is going upwards, so it's a positive correlation. You don't get much spread around that, so they're all clustered quite tightly around the line, so we say that's a strong positive correlation. In number 2, we can draw a line through the middle there, and it's going upwards, and we say so it's a positive correlation, but there's a fair bit of movement around the points now, around the line, so we say that's a moderate positive correlation. There are no numbers around what is a strong correlation, what is a moderate correlation, and what is a weak correlation at this point. So we're just looking at the general feel of it. We're looking for the vibe, the constitution or whatever. So let's go back here. We draw our line through the middle, and we say, yes, they're getting widely dispersed now around that line. So it's a weak correlation. Sort of weakish. It's quite well dispersed. Now, because there's a positive, lo and behold, there is a negative that goes down. So we draw a line of best fit through our graph number 4 here. And we say they're fairly tightly clustered around the line. Not a lot of room. So that's a strong correlation. And then for graph number 5, yes, it's negative. It's a negative correlation. It's getting spaced out, getting a little bit spaced out. So that's probably a moderate correlation. And in our last one here, we can draw a line down roughly through the center of it. But they are getting quite well spread now, aren't they? You can see that they're almost all over the shop, but not quite random. So we can say that's a weak negative correlation, because that's negative, of course. However, just to make things interesting, not every correlation is linear. So we can see from these two graphs here, the top one, which we call 7, the top one, it's quite easy to see that you can draw a line through the middle of it, and it's a positive correlation, and they're clustered quite nicely about it. Now, with this one that we'll call graph 8, it's difficult to draw a line straight through here, so we might be able to say there's a line there, but that leaves out all the things to the bottom. We might be able to say there's a line there, but that leaves out all the things to the right. We might possibly do something like that. Oh, might do something like that, but that doesn't really fit any mold. So we're not happy with that, but we'll probably be happy with a function like that. So we'll probably be happy with that, and that looks like a linear function to me. So where not all functions are linear. So that's a log function. Log function. Causation. We'll give you some examples on causation versus correlation. Causation is where a change in the independent variable forces a change in the dependent variable. So they've used age and strength. We'll give you more examples on this, but causation, one causes the other. The independent variable causes the change in the dependent variable. Oh, well, that's it. Correlation is not causation. Just because two things are closely related in that you can draw a line through them does not mean necessarily that a change in the independent variable causes a change in the dependent variable. And we will talk more about that later.